October 25th, 2010, 16 questions, partial differences, factors of 600. 600 is a fun one to do prime factorization of because it's really quite simple. You can do 20 times 30 or 10 times 60, always with the factor tree. Break it down into, if you break it down into just two factors. And I don't know what I just did here, so I'll delete that and get rid of this, but break it down into two factors, 10, 60, and 10 breaks down into 2 times 5, and 60 is 2 times 30. You see the underlined ones are prime numbers. 30 breaks down into 2 times 15, and 15 breaks down to 3 times 5. So you have 2, 5, 2, 2, 3, and 5. And these are prime factors. This becomes helpful quite quickly as we talk about greatest common factors. Students asked me about all the factors in 600 and chuckled about that because there's so many, but I was pretty impressed that they picked up 24 times 25. I had missed it as we went through. Partial differences, these are answered by students on the board. Just to show you one sample, but they also did it by themselves individually. This question, 145 subtract 177, was a mistake. I was trying to do something a bit different and just wasn't thinking. Most of them got it right. They're becoming quite good at the idea of negative numbers, which is great. On October 26th, we carried on with partial differences, and then we talked about the greatest common factor. And the greatest common factor. Partial differences first. Here's the answer to some of those questions. You can see the decimals and things. And then we went on to partial differences, going through really quite, these were answered by the students. They really seem to get this. And then we went to greatest common factor. So if we see we have 16 and 24 is you can do a factor rainbow and come up with the greatest common factor is 8, but that's very difficult and cumbersome to do. Far better to do the prime factors. Then you just circle the common factors between each one. So 2, 2, 2, 2, 2, and 2. So there's 3 2's in 16 and 3 2's in 24. And then you multiply 2 times 2 times 2 and you get 8, and that means the common factor will be 8. So it's a very useful tool when you get more cumbersome numbers. 35, the prime factors are 7 and 5. 105, it's 5 and 21, but the prime factors are 5, 3, and 7. The only ones that are common are 7 and 5, and 7 and 5. So the greatest common factor is 75. Sorry, greatest common factor is 35, 7 times 5. 24 and 60 is another example. We have 2, 2, and 3 as the common factors. So 2 times 2 is 4, times 3 is 12. Hence 12 is the greatest common factor of 24 and 60. This one, the greatest common factor is 48. But fun to try any two numbers, just throw them out and see if students know it. Today we did 16 questions. We marked the math homework, page 32 and 33, and we reviewed the greatest common factor, and we actually had a little test on it right at the end of class through accelerated math. Not everybody got that completed, but sort of a ticket out the door thing. Anyway, a pretty good one to talk to your students about. To your children about. Thanks very much.